Number 1 asks us to match each equation with an equivalent equation and tells us that some of the answers will not be used. So I would take a look at and read these 3 equations, kind of look at them. Then I would read through all 5 of these to see if you can see anything that sticks out to you. So as I'm looking at these, when I look at B, I feel like an easy way for them to have written an equivalent equation would be to distribute this 3 in. So I'm just going to distribute the 3 in and check just to see if they have this equivalent equation over there. They may or may not, but that's the thing that sticks out to me as something pretty easy. So when I look down, I actually do see that in number 2, they have 3x plus 18. So all they did here was just distributed this 3 in and then left this right-hand side alone. So this B goes with number 2. So then I've narrowed down my choices here. Another thing that I noticed that would be kind of easy to do is these are like terms here. We've got 2 x terms, and these are both constants. So if I just combine those, 4x's plus 3x's is 7x's. And then 7 minus 6 is 1. That's pretty easy. And so if I take a look here, I do see that at number 5. So I can combine this with number 5. So then we just have to get part A, option A, connected to one of these. So if we look at number 1, they say 9x. So what they did was combined these 2, which isn't allowed. So this is a 3x and a 6 that cannot combine to 9x. So number 1, not good. Number 3, they just have 3x, so they've gotten rid of this 6. So this 6 is missing, and they can get rid of this 6, but they have to subtract 6 to both sides, which they did not do because they still have this 7 here. So that one's not going to be good. And then, so that leaves the number 4. So number 4 must be good, but let's make sure in case we made a mistake somewhere else to make sure that it's good. So when I look from A to number 4, I see this -1. And I also see that we're missing the 7. So it looks like they got rid of the 7 from this side by subtracting 7 so that they'd get 0. So then we need to subtract 7 here. And when we subtract 7 here, we get -1. So this would be 3x with a -1, so 3x minus 1. And then this would be 4x plus 0, so just 4x. So number 4 and option A are equivalent. Number 2, my says that equations A and B have the same solution. Here's equation A and here's equation B. Which statement explains why this is true? So how did we go from A to B? So option A says that we added both sides of 3 to the equation. Okay, and that is not true because if we added both sides as 3 here, whoops, and we'd add it to A. So if we did add 3 to both sides, then what we would have is still -3 times x plus 7 because we can't add anything in there because of this multiplication. And we would have a +3 on the outside. And then 24 plus 3 would be 27. So option A, not going to work. Option B, apply the distributive property. So if we apply the distributive property here, that just means multiply this in to both things in the parentheses. So we would get -3x, -3 times +7 is -21, and then 24. So that didn't get us to this x plus 7, so that's not true. Part C, by subtracting 3 from both sides. So instead of adding 3, we would subtract 3. So again, we wouldn't be able to get into these parentheses, so that would have to stay the same. Then we would have a -3 outside. And then 24 minus 3 would be 21. So that doesn't get us to that equation. So then the last one, D, says that we would divide both sides by -3. So if I write this down again down here, so if I divide by -3, now we can divide these because there's multiplication here. So it's -3 times this whole thing, and then divide by -3. So -3 divided by -3 is 1. So we just get x plus 7. And then we don't need those parentheses anymore. And then 24 divided by 3 is -8. So then we do get that. Number 3 is 0 a solution to this equation. Explain or show your reasoning. So I think there's maybe two ways you would do this by just plugging 0 in. So we could just plug 0 in and check that it's the same on both sides. So 2 times 0 plus 10. 4 times 0 plus 10. A solution would mean both sides are the same. So 2 times 0 is 0, plus 10 is 10. 4 times 0 is 0, plus 10 is 10. Both those sides match. So yes, it's a solution because both sides match. You may also want to just solve the equation to see what the solution is and see if it is 0. So in order to solve this, maybe you would subtract 10 from both sides. So then we would get 2x plus 0, so just 2x. And then 4x, 10 minus 10 is 0, so we would just have 4x minus 0. So then we want to get these x's to the same side. So I'm going to subtract 2x from both sides. 2x minus 2x is 0. And then 4x minus 2 is 2x. Then we want to get x by itself, and we have this 2 times x. So we want to divide by 2. And 0 divided by 2 is 0. 2 divided by 2 is 1x, so just x. And then we see that x equals 0 is a solution. So then either way would prove that it's a solution. Number 4, Kieran says that a solution to the equation x plus 4 equals 20 must also be a solution to 5x plus 4 equals 100. Write a convincing argument. So if we look here, we can see that they've just multiplied this 5 to the left side, and then 20 times 5 is also 100. So write a convincing explanation to show why this is true. So this is true because if we multiply 5 to both sides of the equation, x plus 4 equals 20. And then let me get this so this stick stays together. We will get 5 times x plus 4 on the left and 5 times 20 on the right. So 5 times x plus 4 equals 5 times 20, which is 100, right? So maybe I'll just put in here equals 5 times 20 or 100 on the right. So therefore, 5 times x plus 4 equals 100. 100 is equivalent to x plus 4 equals 20. And equivalent equations have the same solutions. Now, your argument could obviously be different than mine. That's just my words, so feel free to write it in your own, more or less than I did. Just needs to be convincing. The Entrepreneurship Club is ordering potted plants for all 36 of its sponsors. One store charges $8.50 for each plant, plus a delivery fee of $20. The equation 320 equals x plus 750 times 36 represents the cost of ordering potted plants at a different store, at a second store. What does the X represent? So if we're buying shirts and there's a delivery fee and there's a shirt fee, okay, your shirt fee is going to change per the number of shirts that you buy. So this part of the equation would look like it's going to be the cost of the t-shirt $7.50 and that we're ordering 36 t-shirts. So this X portion, so this X portion is going to be that delivery fee. Number 6, which equation is equivalent to 5x plus 30 equals 45? So A is not good. Remember, these are not like terms, so you cannot combine those to 35x. The next one has the 5x by itself, so that means we would have had to have gotten rid of the 30. And in order to do that, we would subtract 30 from both sides, because then this would be 5x plus 0. Whoops, not 10. 5x plus 0. And 5x plus 0 is just 5x. So then we'd have 5x equals 45 minus 30, which is 15. So not 75. Then part C takes a 5 out. So it looks like it's factoring a 5 out, which means if we multiply the 5 back into both pieces, it should equal out to the original. And so it does equal out to the 5x, but then 5 times 30 is 150. So that's not going to be good. But in part D, they did it correctly where they took the 5 out of the 30 as well. So here, if we multiplied in, we would get 5x plus 30 equals 45, which is equivalent to the original. Number 7, an environmental science club is printing t-shirts for its 15 members. The printing company charges a certain amount for each shirt plus a setup fee of $20. The t-shirt order costs a total of $162.50. How much does the company charge for each shirt? So we've got this total. We know that we're paying the setup fee one time. So we're just going to take this out of the total. So then $142.50 would be our t-shirt cost for all the t-shirts, right? So the total t-shirt cost. So now if we want to figure out per t-shirt, then we would just take and divide by the number of t-shirts we needed, which would be 15. And when we do that, we get $9.50 per t-shirt. Number 8, the graph shows the relationship between the temperature in degrees Celsius here on the vertical axis and degrees Fahrenheit on the horizontal axis. Mark a point on the graph that shows the temperature in Celsius when we know that there's 60 degrees Fahrenheit. So we're going to go to 60 degrees Fahrenheit here, and let me change this. Oh, we're just doing a point. Okay, so go to 60 degrees Fahrenheit and go up to the line and put a point. So then there's your point when it's 60 degrees Fahrenheit. Part B asks us to mark a point on the graph that shows the temperature in Fahrenheit when it's 60 degrees Celsius. So now we're looking on the vertical axis and going over to the equation. So we want to go here to go all the way over to that because we knew the 60 Celsius versus here we knew the 60 Fahrenheit. C tells us that water boils at 100 degrees Celsius. Use the graph to approximate the boiling temperature in Fahrenheit. So we know 100 degrees Celsius, and then we want to go up here and figure out how much Fahrenheit that is. So we'll go here over to the graph. So here's our 100 degrees Celsius. and then we'll go down and figure out that that's about 210. And really, I think it's 212 is the actual boiling temperature for degrees. But somewhere around 210, you're just approximating it. All right, then the last one on this question asks us to, or gives us the actual equations. Now they're giving us this equation here for Celsius equals 5/9 times Fahrenheit minus 32, and they want us to use it to calculate when the temperature, what the temperature is in Celsius when it's 60 degrees Fahrenheit. So now we're actually going to plug this in and confirm our answer from A. So we have Celsius equals 5/9 times, and we know that we're looking at 60 degrees Fahrenheit, so that's going to go in for F, and then we minus 32. So we'll follow order of operations here. So we'll do 60 minus 32, which is 28. And then we'll multiply, we'll do 5 divided by 9 times 28. And that gives us 15.5 repeating, so like 15.56. And if we look up here, we can confirm that that's pretty close to what it is. So if we look over here, it's going to be between 10 and 20, so it makes sense. Number 9, select all equations that have the same solution as 2x minus 5 equals 15. So we're just finding equivalent equations. So if we look at A and B, they both have 2x by itself. So if we look at this equation, so 2x minus 5 equals 15. If I want the 2x by itself, I just want to add 5 to both sides, so that this is 0. So we get 2x plus 0 equals 20. So A is not equivalent, but B is equivalent. In C, it looks like they tried to divide the 2 out. So remember, when we factor the 2 out, if we multiply it back in, it needs to be the same. And when we multiply this in, we get 2x minus 10 equals 15. So that 10 is different. So then C is not equivalent. For D, the parts that have changed are this negative 20 and this 0. So if we take this equation here, let's make this right side 0. So let's get rid of this 15 to both sides to see what this number needs to be. So negative 5 minus 15 is negative 20. 15 minus 15 is 0. That is what they have here. 2x minus 20 equals 0. So this is equivalent. Just subtracted 15 from both sides. For E, when we look at it, we see that every term changed here. And so if we look, it goes from 2 to 10 to 20. So that's just taking 2 times this. So if we take 2 times both sides, 2 times 2x is 4x, 2 times negative 5 is negative 10, and 2 times 15 is 30. That's what they have in E, so E is equivalent as well. And then the last one, they switched it around. Okay, so they have this, we originally had it like this. So then we switched these around, which is fine. So we can move the 15 to the left side and the 2x minus 5 to the right side. But what we can't do is switch these over subtraction. So you can't switch these 2 places. You can switch them if you keep the negative with the 5. So the 5 is negative and the 2x is positive. We can do that, but they all of a sudden have a negative 2x with a positive 5, and that you cannot do. Number 10, Diego's age D is 5 more than 2 times his sister's age. This situation is represented by this equation. Which equation is equivalent to it? So we're going to pick one equation here that's equivalent. So for A, we see that they all of a sudden have parentheses. So we're going to look at if we multiplied this in, we would have 2s plus 10, which is not equivalent because this is 2s plus 5. B has D minus 5 and then the 2s alone. So if we take a look at this, if we subtract 5 from both sides, we get D minus 5 over here. And then plus 5 and minus 5 is 0, so we just have 2s. And that matches this equation. So by subtracting 5, we obtain an equivalent equation. So that means the rest of these are not equivalent.